If you write C or C++, two compiler names come up everywhere, GCC and Clang. Both take your source code and turn it into something a CPU can run, but they were built with different goals, different licenses, and different trade-offs. Here's what each one actually is, how they compare, and how to pick the right one for your work. A compiler is a translator. It reads the C or C++ code you write, human-readable text, and converts it into machine code. The raw binary instructions your CPU actually understands. That translation happens in stages. A front end checks your code for errors and builds an internal structure. An optimizer rearranges things for speed or smaller binaries. And a backend generates the final machine instructions for your specific CPU. After that, a linker pulls everything together into a single runnable file. GCC, the GNU compiler collection, has been around since 1987. Richard Stallman created it as part of the GNU project, so the free software community would have a compiler it fully controlled. Over nearly 4 decades, it's grown to support a huge range of languages, not just C and C++, but also Fortran, Ada, Godot, and others. It's the default compiler on almost every Linux distribution and has been battle tested on everything from Raspberry Pis to the world's fastest supercomputers. The catch is the GPLv3 license. If you modify GCC and distribute it, you must share those modifications under the same terms. That's a real problem for some commercial tool builders. Clang appeared in 2007, built by Apple on top of LLVM, a modular compiler infrastructure that started as a research project at the University of Illinois. Instead of trying to support every language, Clang focused tightly on C, C++, and Objective-C. That narrow focus let it solve problems GCC wasn't great at. Plugging into IDEs for real-time code navigation, running static analyzers over your code, and producing error messages that actually point at the problem and suggest a fix. Its Apache 2.0 license is much more permissive than GCC's GPLv3, which made it the obvious choice for companies building commercial developer tools. Today, Clang is the default compiler on macOS and FreeBSD. Let's put them side by side. On compile speed, Clang generally builds faster. You really feel it on large C++ code bases with heavy template use. Diagnostics are where Clang made its reputation. It points to the exact problem, underlines it in your source, and often suggests the fix. GCC has gotten much better at this, but Clang set the standard. For raw optimization, meaning how fast the final binary actually runs, GCC still holds a slight edge in many benchmarks. Thanks to decades of tuning, though, the gap keeps shrinking. And the license difference is straightforward. If you need permissive licensing for a commercial product, Clang's Apache 2.0 wins without debate. In practice, switching between them is almost trivial. This little C file compiles with GCC by running gchello.c-o-hello, and with Clang by running clanghello.c-o-hello. The command line flags are nearly identical. Clang was designed as a drop-in replacement. In fact, on many macOS systems, running the GC command actually invokes Clang behind the scenes. That interchangeability is a big reason Clang spreads so quickly. Developers could try it without changing anything about their build setup. If you're doing general C or C++ work on Linux, GCC is the safe default. It's already installed, it's thoroughly tested, and it's what your distribution's packages were built with. On macOS, you're already using Clang whether you know it or not. If you're building developer tools, linters, refactoring engines, code completion, Clang's library-based architecture makes that dramatically easier than with GCC. And if your project can't accept GPLv3, that alone eliminates GCC. For niche architectures like AVR or some embedded targets, GCC often still has the stronger backend. But for most everyday work, both produce fast, correct binaries. The differences only show up at the margins. GCC and Clang aren't really enemies. They push each other to improve, and everyone using C or C++ benefits from that. Try both, see which error messages you prefer, and don't overthink it. If this was helpful, subscribe to Awesome Linux TV for more deep dives into the tools behind your code.